Hello, everyone, and welcome to Math Essentials for Designers. My name is Jason Pitre from Genesis of Legend Publishing. You may know me from such games as SIG's City of Blades, After the War, or the RPG Design Panelcast, which is rebroadcasting all of these panels afterwards. And I wanted to set up this panel to demystify and de-terrify math in games. I'm joined by some incredibly talented and much more qualified folks on both sides of me. So let's let them introduce themselves. Mags.
I'm Mags Maenad. I'm a professor of analytics, but I'm also a member of Cold Hearth Collective, which is a group of us who primarily create trophy stuff, but we've also branched out into Troika and some independent games. I kickstarted last year, 2 years ago, 2020, Climbing the Witch's Tower, so you may know me from that. But yeah, as my day job, I talk about analytics, and I'm also a statistical consultant and tutor. So if you have any questions about statistics, reach out to me. BJ?
Hi, I am BJ from the Philippines. I have been dabbling in RPG design here and there, mostly D20 derivative products. I have contributed to Pathfinder 3 Bestiary. I have also contributed to Arc by Momentos. And where else did I go recently? I am also going to be on Down We Go, which is an OSR game that is going to come out fairly soon. Um, that's on the RPG side of things. I try to keep my RPG and my math side different for on the day to day. On my professional work, I am working as an actuarial candidate. That means that I deal with probabilities on a day to day in a corporate setting. What is important, I guess, here is that I wrote my actuarial exam for probability way back in 2010. So it's been a while, but it's knowledge that's supposed to stick with me, and it does come up in the office a lot. So there. Oh, I'm also part of RPG SEA, role playing gamers of Southeast Asia. There.
You are muted.
Jason, I think it's muted.
Fantastic. So the key goal of this panel is for us to generally reveal the fact that math for games is actually not as scary as you'd think, and to provide a bunch of very simple tools to help you deal with the most common problems you might face. So there's a lot of basic statistics here, explaining a few terms, and generally giving you the basic tools to address the problems in front of you. This means we're going to be digging in a lot on how dice work and how cards work, for obvious reasons. So how do we want to get started? Mags, what do you think? Should we explain the difference between dice and cards?
I mean, obviously, I'd love to do that. So sure, yeah. I think so. One thing is that dice and cards both work excellently as a physical manipulator, but then we also use them to generate random numbers, right? We want some element of randomness in the outcome of something. So we want to roll something or draw something to say, hey, how does this go? Or in a pass-fail system, does this happen? And so dice and cards both serve to do that. However, dice are uniformly distributed. So when we roll a die, if it's a fair die, it's equally likely objectively that all phases show up, right? So we might see any number. If it's a 1d12, we'll see any number between 1 and 12. But with cards, when we have a deck of cards, once we've drawn one, it's no longer in the deck. So I guess that was the weird end cap of the card. So let me draw in the middle. So here I have a 7 of diamonds, but now it's not in the deck. So when I draw, I won't be able to draw the 7 of diamonds again. So that I think is a primary difference. And so even though distributionally you have 13 face cards, so it might be very similar to rolling 1d12, and initially your probability of seeing each kind of card is equal, it does work very differently. And so tools to simulate this, especially if you're not shuffling the deck every time, are really important. So that's just a brief introduction of the difference between dice and cards. I also really like dice for a bunch of other reasons. And so I know that this isn't a panel about what's nice about cards, but you get to make yourself a hand, right? So you can build a hand of cards. And I think from a cognitive perspective, sitting down at the table and giving people a fidget toy that they can sit there and play with actually really does help things. Also, this was something I said before, and I just want to talk about it early on, is to say that not only is math for games really not that scary, there are lots of tools that you can use to help and people who are willing to help you. But also, you as the designer are going to think more about the math in your game than any of your players. So in general, even statistically educated people do not emotionally understand probability. Like if you tell someone there's a 5% chance that this happens, they don't know what that is, right? And they can say, well, I understand the number 5 and I understand 5%. But people emotionally expect things to happen more or less frequently pretty often, depending on whether they're risk averse or risk taking. And so in that sense, I think thinking about what kind of people you want to play your games and what you want their experience to be is really important as a designer. And it affects the play experience, but it's very rare that you'll get a player who is like, oh, but there's only a very small chance of that happening, and actually understanding the probability of your game better than you would. Jason, are you? Okay.
Could one of you explain the Monty Hall problem?
I would love to, but BJ, you haven't spoken.
No, well, I'm not familiar with it. I actually want to hear about it.
Okay. So I'm going to use cards for this because I just picked up my deck of cards. And so here we have them. So here I have 3 cards, and I can put them back to you and shuffle them around. And I can say, okay, pick the face card. And you can pick one. And I say, okay, so out of these remaining 2, I'm going to take one away, and it's definitely not the face card. And so now between these 2 cards, which one is the face card? Do you want to keep your original guess, or do you want to switch? So the answer is, with your original guess, you had a 1 in 3 chance of being correct, which meant that you had a 2 in 3 chance of being wrong. And that 2 in 3 chance becomes concentrated on the remaining card, essentially, because you remove all of the wrong options from the ones that you didn't pick. And so when you're given that option, you always want to switch. But that's a great example also of player psychology, because nobody believes that. Like if you in the audience are saying that doesn't sound right, what do you mean the probability becomes concentrated? Probability doesn't lock in, it doesn't change. You're not alone. Most people would say, once you've taken away that 3rd card, it's a 50-50 chance. And it's not, and you can simulate it, it's really not. But ultimately, it's a great trick if you want people to choose something suboptimal. You can set things up to be essentially a Monty Hall problem in your game, actually. Because player choice, players will usually pick the bird in the hand. Just because they had an emotional reason for choosing that card in the first place.
Yep. So, BJ.
Yes.
If I roll a 20 on a d20 2 times in a row, what is the chance I'm going to roll a 20 on the 3rd roll of a d20?
It's the same. It's still 5%. Dice have something called weird? The lack of... Yeah, it sounds weird because we're very superstitious about our dice, right? And like, oh, this die is rolling badly for me today. I'm going to banish you, or I'm going to do some ritual to make you roll better. But the thing is, dice a die roll is an independent event. What it means is that there is nothing that has happened before that will affect the outcome of this roll. So just because you roll 2 20s in a roll doesn't mean it will roll one. It still has a 5% chance of rolling one and a 5% chance of rolling 20, assuming, of course, that you have a fair die.
Yeah.
Which is a different discussion entirely, I think. So, and in my experience, dice actually tend to roll fairly well, fairly evenly distributed, even those that are not that well made, because that has come up when I was younger, when I was like starting into probabilities. I was looking at dice and I'm like, oh, this die looks a little funky. Let's try rolling it a bunch of times. And there is a thing in probability called the law of large numbers. So if you roll it a certain number of times, a large amount, and then you tally it, it becomes a fairly good approximation of what it actually is. So I looked at the dice that I thought was biased, and I rolled them like I took the time to roll it like 400 times, and then I tallied each one, and I took the average. I took the mode. It's not going to be even. It's not going to actually. It's not actually going to roll a 5% of the time, but it's going to be fairly close. It's going to be like 4 point something. Some outliers will be like 8% on that particular sample. It's not indicative of what will happen on the next 400 rolls because again, there's a lack of memory property. So to get back to my original point, our dice in general um, tend to be equal opportunists, and it's just our tendency to remember the bad rolls and the good rolls that make us think that they're biased one way or another.
Now, to show something that's a little different is, yes, the chance of that third die be showing up as a 20 is 5%. However, the chance that when rolling 3d20, you will get 3 20s is, I believe, 1 in 8,000?
20
yes.
raised to the third
Yeah,
power.
20 to the
So,
third
yeah.
is 8,000. Yep.
So it's a 1 in 8,000 chance that I pick up 3 d20s and they're all going to show a 20. But the difference there is the probability space is wide open when I'm doing that. Whereas we've already locked in numbers in that first situation. So there's all sorts of psychology of dice to play around here. But in broad strokes, don't worry that much about having the math perfect. So long as it feels right, it's probably good enough for government work. Saith the bureaucrat.
Also, mathematicians are jerks, and we all just want to make fancy words for things that are actually really simple. So I could argue like a sequence of independent events, which is you rolling the same d20 all night. That's called a Markov chain if you're a mathematician. So your D&D night is a Markov chain. Okay, I'm done.
So, which one of you would like to explain what Monte Carlo simulation is?
I've done that at work once, and then I forgot. So actually, before we go into the Monte Carlo evaluation, that's actually something that I would also like to bring up. As a game designer, you don't have to know everything. Like a Monte Carlo evaluation, I've forgotten what it is, but I could, when I need to use it, I can look it up again, and within some time of studying, like 30 minutes, hours, 30 minutes, I could start using it again.
Yeah. So Monte Carlo sounds like the name of a casino, and a casino is a place where a lot of random things happen. People are constantly drawing cards and rolling dice and pulling a slot machine. Thieves don't play slot machines. That said, Monte Carlo is just essentially that. It's simulating something a whole bunch of times. So drawing a bunch of random samples, so rolling a d20 500 times, exactly what BJ just described doing, and seeing what happens. So,
which means this is an incredibly powerful tool for any designer, because if you don't know how to solve a problem, the actual statistician-approved solution is do it a bunch of times, write down the answers, and look at what came out. That is called advanced statistics and Monte Carlo. And like that's literally it. The thing is, typically for those kinds of simulations, they use computers and model it millions of times because it's more accurate. But
Yeah, but on the other hand, if you have friends who are statisticians, we could probably write a script to do that in like less than an hour, depending on how complicated. Just saying.
So I have used that to brute force my way through a lot of problems. And it's remarkably simple. Because all you have to do is try the thing that your mechanic says and just write down what the results are. That'll work pretty much all the time. So long as you don't have an incredibly complex and convoluted mechanic. So let's talk about the magic of the bell curve.
Yay.
So there are 3 different terms that you might hear, which are what the sort of average is. The mean, which is literally the standard average. You add everything up, you divide it by the number of things. You have the median. If you rolled 13 dice, what is the middle number in the sequence? So what is the 7th number? A 7th die in that 1 to 13 sequence. And mode. This is the number that comes up the most often. These are all very different things and can give you very different results. For instance, if the 3 panelists here and Bill Gates are sitting in a room, the mean income is billions of dollars per person.
I'm rich, guys.
The median income is significantly lower than that. There is actually a discussion about millennials' wealth, and millennials' wealth is actually the mean is dragged up by Zuckerberg.
Yeah. We call them like right skew distributions, which tend to be like income distributions and stuff, which just means that there's a few people who earn a lot of money, and so they make the average seem a lot higher than where the rest of us are. Although I will say, if you put me in a room with Bill Gates after I beat him up, my income will also be in the billions of dollars, and so then we can solve some of the world's problems.
Yeah.
Sorry, I don't mean to threaten violence on any living person.
That is a pure hypothetical for the purposes of the internet. So
what are the odds of us meeting Bill Gates? Like, especially for me, I don't even live in the same country. If he sees me, he's probably donating money to my country or something.
Right. But
I will say that there's also the concept of an outlier. I think wherein everything else, every point in your data probably behaves a certain way that you would more or less expect, and then there is an outlier event that skews everything towards that if you include the outlier. And that's why in a lot of in a number of surveys, they have a tendency to mention that the outlier of this amount was removed from the sample because it is no longer indicative of what is being looked at.
So if you have a friend who comes to your game night, and they roll, I'm going to use a d20 just because it has the most values, but they roll a d20 like 20 times over the course of the night, and every single time is over a 17, that could be an outlier event. it's unlikely to happen, but it could have happened. But if they come to your game night and every time they never roll below a 17, stop inviting them. They're cheating. Because like unusual things happen. Like the truth of statistics is that rare events do occur. They have a low probability, but they can totally happen. But they shouldn't happen consistently.
Now, so we've explained the basic terms, mean, mode, etc. So the bell curve. Anyone who has dealt with Powered by the Apocalypse systems will know the famous 2d6. And the standard breakdown for PBTA games is 6 minus, 7 to 9, and 10 plus. So why do they have those specific numbers? Eric, if you could just toss the probability one in the chat. The chance of getting a 6 minus is 41.66%. The chance of getting a 7 to 9 is 41.66%. The chance of a 10 plus is 16.66. So you have the equal chance of failing or of getting a mixed success and a low chance of a full success, of a full hit. And that gets significantly shifted around by modifiers of +1 or -1. So that is effectively they took advantage of the bell curve to figure out where they wanted the majority of the results to be. And that's how they came up with those numbers. You can actually replicate the same curve through other means. You can replicate that roughly using a single d20, for instance.
You can also, if the numbers feel arbitrary to you, 1d6 minus 1d6 has the same distribution as the sum of 2d6, but it's centered at 0 instead of being centered at 7. So, like...
Yeah. Which is also fate dice.
Mhm.
So, fate dice, you're rolling 4 fate dice. Each die has 2 plus signs, 2 neutrals, and 2 negatives. All that does is it sets up a bell curve centered on 0.
0, yeah.
That says that your result can be plus or minus 4. That's the range of probability for any given roll. It could be at most +4 over the base number, and at least -4 below the number. That's it.
On that note, well, since we've brought up fate, actually intent starts to come into play here because with faith you have 4 dice, and each die. I'm not sure if everyone's familiar with the fate die, right? You have 2 negatives, 2 blanks, and 2 pluses. So effectively, we could map that to -1, 0, and +1. But because there are 4, the thing about the bell curve is that as you add more dice, it quickly becomes closer and closer to a normal distribution. The bell of the bell curve starts to get more pronounced. But also, we're looking here at a value that is centered around 0, and it's going to be a little bit flatter than your 2d6, which is a bit taller, I think. Please feel free to correct me. It's been a while, but I think that's what happens.
It does. 2d6 is actually, it's still hump shaped, so it's centered in the middle and it has some variation, but it's a triangle distribution actually, and not a true bell. And as you do add more dice, and the normal distribution is not the usual distribution, it is in fact a specific mathematical object that is complete magic, and statisticians worship it like other people might worship the devil. So
Thank you. To get back to the point that I was making is that it becomes intentional, I think, because here you're going to have a lot of plus zeros. So the dice become, I wouldn't say unimportant, but less important in this case. Your stats of plus 0 to plus 4, if I remember fate correctly, maybe plus 5, they become more important because now it becomes pretty much your information that if I need to pass a difficulty of 3, it would be really helpful if I have a plus 3. So, and the way the game works is that it creates tension by banking on the idea that sometimes you will roll outside of the normal, but on the not normal in the math sense, normal in the expected sense. Um, but most of the time you will roll what you expect, and when it doesn't roll what you would expect, then you would use your aspects to re-roll or to add a plus 2, and that becomes a game that is more or less it flows. The story just continues because more or less the player will expect to know what happens when they actually do roll, outside of a few edge cases which could be narratively interesting.
I
So,
think that
sorry. What is the chance of getting each result on a fate die? You have a 2 in 6 chance of a minus, a 2 in 6 chance of getting a blank, and a 2 in 6 chance of getting a plus. You can extrapolate that out. And what are the chances on 2 fate dice? And what you're doing there is you're figuring out the number of potential numbers that you can choose from, and you can easily figure out what's the chance of getting each number that way. Sorry, I'm confusing things. I'll punt it to someone else because my brain just fried.
Well, I did want to say, so we've talked a little bit about mean, and so something that we call mean is the expected value. When you roll some dice, what number do you expect to see? But of course, the number that you expect to see isn't going to come up all of the time, and in fact, isn't necessarily going to come up most of the time, right? On 2d6, we expect to see a 7 for the sum, but that's going to come up 6 out of 36 times, so 1 in 6 times. It'll come up as a 7. So not the majority of the time, but that is the expected value. But then when you don't land on the mean, we can ask how far away from the mean do you expect to fall, right? So how far above or below average do you expect to do? And that is what we call standard deviation. So it's another factor about statistical distributions. And so when we say what BJ was talking about really did hinge on, as these distributions converge and as you add more dice, you often actually reduce the variation. So you're reducing the standard deviation, which can be good or bad. So if you have players that really like it when they catastrophically fail or catastrophically succeed, maybe you don't want to add more dice because then the average thing will happen more often. But if in the case of fate, you can control the narrative, then maybe it's okay if most of the results are average because players will add their own narrative spin on that. And so, yeah.
I want to verge from that and say that it's actually one of the pet peeves that I have when I'm looking at specifically D&D forums. I've got to talk about 5e now. Is that I hear it, I read it said a lot that granting advantage or granting disadvantage is effectively a +5 to your average, and I'm like, where did you get that number? The thing about it is, first off, you're no longer comparing two uniform distributions. A d20 will equally likely to roll any of those 20 numbers in succession. Once you roll with advantage, then you skew it so that the bump is on the right. Is that skew to the right or skew to the left? I forgot.
It's
But
left skewed.
left skew.
The long tail is the direction that the
The
skew
skew.
goes.
Okay. English hard. Apologies. But Yeah, it becomes left skewed because your bump becomes centered to the right. And I seem to remember computing that before and rolling with advantage on a d20 without the modifiers. I think I could be wrong. Goes up to an average of 13.875. I want to say I could be wrong, but that is not yet indicative of what it does. Now you go to, as Meg said, you go to the standard deviation because the standard deviation of a roll with advantage is smaller than the standard deviation of your uniform distribution. So what happens is that a lot of the results will will center around that 13.8 number. So you would expect more of your results to be around um, 12, 13, 14, 15, which I suppose you could simplify into a plus 5, minus 5, but that doesn't sit right with me. That feels wrong. So if you see that in a forum of some sort, you're like, that person does not know what they're talking about.
Yeah, I think advantage and disadvantage, because when you add more dice and you select the lowest two, what you are doing is kind of causing the distribution to lean either to the right or the left. Right if you take the highest couple, and left if you take the lowest couple. But just in terms of how player psychology works, it would be the same or it's very similar to if you invited someone to re-roll. Like statistically, those two things, if you're like, okay, re-roll that and take the higher of the two rolls, that's basically the same as rolling with advantage, but it feels different for players. And so the statistics work out to be pretty similar, aside from the condition of people don't usually want to re-roll unless they rolled badly, and so you end up with like a conditional thing there. But if you just said, hey, you can re-roll if you want to, um, it's the same as rolling with advantage, but players feel like it's different. And so use that as you will. But
So, the magic normal distribution bell curve that we're talking about, to bring this back down to something very simple, you've got a roughly 68% chance of being plus or minus one standard deviation. 68% would be within that middle bit. And that's all we're doing. So for instance, when I want to figure out, hey, what's the likely range that someone's going to get? I look at standard deviations and I say, okay, these are the likely. It is more likely than not that the numbers will be within these ranges. Am I comfortable with that? And that's how I do the calculation. That's all it really is.
yeah.
If something is two standard deviations, then it includes stuff that's further out, and there's an even greater chance that you are within two standard deviations.
95%. So the same as rolling not a 20 on 1d20. There is a 95% chance that you fall within two standard deviations of the mean. Sorry.
Something that comes up when we talk about standard deviation is that the formula for standard deviation looks wonky already from a lot of people who are not necessarily mathematically inclined, right? And this is, I think, a good chance for us to talk about how you shouldn't worry about it because as long as you either follow the formula or you got a statistician to verify what you did, then it's just a matter of putting numbers into a formula. And it doesn't really forget all those times in high school where you had trouble memorizing a bunch of because I don't have it memorized. um, I probably could if I'm studying to write an acquiral exam. I mean, I could if I because that's something that I so point is it's only important when it's not important at all to understand the archaic wizard-like formula that shows up with the square root. It's a square root because it's the square root of the variance, but that's something that's more interesting if you are a mathematician or a statistician. That's what I'm saying. You don't
Um,
have to.
Also, a lot of what we're talking about is the frequency distribution, right? And so ultimately, if you look at the frequency distribution and you say, okay, how often, you don't necessarily have to calculate the frequency distribution from the mean and standard deviation, which is what a lot of us statisticians do on a regular basis. You can simulate the frequency distribution and say, okay, how often would you miss? How often would you succeed? How often would you get a mixed success? And if you can generate the frequency distribution just by rolling your dice and doing your random roll as many times as you would like, then you can ask these questions. You don't necessarily need to go all the way to standard deviation and then back to understanding the distribution.
So, couple other things. One, let's say at 2d6. Sometimes what you want to know is what is the lowest number you can get and what is the highest number you can get. The lowest number is 2. The highest number is 12. Sometimes that's all the information you need to know. Will a 2 or a 12 break your system? If so, don't use that. Sometimes it's that simple. Now, there's a bunch of tools on the magic that is the internet that you can take advantage of that will greatly simplify things. Probably the most useful among these is called AnyDice. It is literally anydice.com. And what you can say is, it'll pop up and say, output 2d6, and you can change that to 4d6 and see what it looks like. And it'll show you all the fancy graphs, tables with probabilities, all that, and that will handle any kind of math, like any kind of probability that you might think of for basic dice work. And it'll just do it for you magically.
I didn't know
Similarly,
that this existed.
oh, it's super useful. And there's also complex function stuff that you can do, exploding dice, middle number of dice, sort them, count. Like there's all sorts of cute stuff in there. The other thing is, whenever you, a basic principle is find out what the math magic word is for it, and then just search calculator. Permutation calculator in Google. And that will tell you what how to figure out the number of permutations. Permutations and combinations are extremely useful things, and I'm going to let someone else explain it because I've got the brain of a kumquat right now. So what is a permutation and combination?
How many hands of 5 can I draw from a deck of cards? That's a combination. I have 52 cards, and I'm drawing 5 of them, but I don't care because they're all in my hand, right? Versus when we talk about Texas Hold'em and we talk about the river versus the flop and the order in which the cards come out matter, now we're talking about permutations because we care about order. And so there are always more permutations because, for example, here I have a hand of 5 cards, and this is the same combination regardless of how I order the cards. It's the same combination. But here I have 5 factorial possible permutations because each possible different ordering is a unique permutation. And so it's a fun thing about deck builders because ultimately, like, the order does matter. If you're playing a deck builder, which, and the card that you flip over first matters. And so, and if you're only drawing, 2 cards from your deck of 32, then you really do care what order they were in the deck. But there are so many possible permutations that I think it's very difficult when you're building your design.
I think for permutations and combinations, from a layperson's perspective, the important thing to note about them is that they are counting principles. It's exactly what it says on the tin. They are methods of counting how many ways you can get your particular, I wanted to say combination, your part to get your combination. So it's important because when you are doing probability, you have to know first how many possible outcomes there are before you could then go into how many favorable outcomes do you want out of those possibilities, and that's how you build your typical probability for any particular event. And also, can I also say more cards and deck building mechanics in RPGs, please?
Yes, please.
I love them. I'm gonna segue a little bit. I actually started with a geek hobby with Magic the Gathering way back in the '90s when I was a kid, and at the time, especially as at the time when I tackled probability lessons in high school, early college, even as a mathematics major, I've always hated it because their examples have always been, you have an urn, and the urn has 3 red balls, 2 blue balls, and 4 yellow balls. Like if I take 2 balls, what is the probability that one of them is blue and the other one is yellow? Like that doesn't really tell me anything interesting. It doesn't interest me. But when I finally put it together as a Magic the Gathering player, they're like, actually, that's basically like Magic, isn't it? You draw 7 cards. What's the probability that I have 3 lands, which is what I want at the start of my hand? So
You
this
have a
becomes
deck of
important.
40 cards, and 15 of them are fire, mountain, whatever, red.
Yeah.
What is the probability that 4 cards in your hand are mountains? Yeah, sorry.
Yeah, and as a practical example, when I am designing a game, I will try to look out what are the different combinations that can for character types. So I have one of my games after the war. You have 20 different choices in column A, 20 different choices in column B, 20 different choices in column C. So you can calculate how many unique kinds of characters you've got there. Like you can, likewise, you can calculate how many combinations of D&D 5e classes plus races there are. So you can see how many different kinds of fighter can I be? Well, the answer is that there's 9 different races. There's 1 type of fighter, so that's 9 different kinds of fighter. So things like that, you can figure out how much variety your game gives just by looking at the number of combinations, and your permutations won't matter. Like there's all sorts of interesting stuff in that space that you can find particularly useful. So,
Oh, sorry.
I was just gonna say, do we have any questions from the audience?
We actually do. Clark Valentine asks, have you seen any game designs fall into a trap where a dice system had some unintended consequence that negatively affected the game? Or is there a way to avoid a trap like this other than have a probability expert review the design?
So,
Just checking, can the audience hear that? I don't think so.
Yes.
So
Yeah.
Oh, yes.
Yes.
yeah.
Great, thank you.
So, I think as a designer, it's really easy to think about the whole distribution, right? And we've been talking a lot about what the whole distribution is. But a big design that I've seen, or a big design trap that I've seen that happens, is that people want to build in these rare, and then something really cool or really awesome happens that isn't in the tone of the game. But the issue is players typically only play a game once. They'll only see one realization of it. So if it doesn't fit the rest of the game, and you're like, okay, but there was only a 1 in 8,000 chance that happened, it might happen for somebody. So if you want something to be nearly impossible, make it impossible, because Yeah, I've definitely I've had the experience where just the numbers add up in such a way that you're like, well, that doesn't make sense narratively. And so yeah, I would avoid that.
So I have
I
a real fun anecdote of where these kinds of things fall apart, and a math trap. Amusingly, our moderator was a playtester for the game in question. So, for my game after the war, I had expected that you would not have ties very often because you were rolling each side would roll a die pool of d6s between 1 and 6 dice. So
Mhm.
what's the likelihood that person A rolls 4d6, person B rolls 66, and you're going to happen to land on the same number? That's not, that's a huge variety. It's not likely. It kept on happening. And we were really confused at why it was happening. There was a system in place that said that if you were losing after you rolled, you could spend currency to re-roll as many of your dice as you would like. This meant that any time that you had a chance of succeeding if you rolled the dice, you would spend the currency. And you would only have a small chance of getting high enough to go over the opponent's result. So it meant that it was effectively shoving you right up to the maximum result because you'd keep on re-rolling to try to get closer and closer to your opponent. So we were getting ties like every 4 rolls because we had a re-roll mechanic that encouraged people to break my perfect stats, that objective stats that assumed that there was no that everything was independent.
Mhm.
Whereas no, they were totally dependent because players were looking at the numbers saying, well, okay, it doesn't matter if I reroll these dice, I'll never win. I'll never spend the money. Oh, I have a chance of winning. It's a small chance, but it's a chance. So I'll keep spending money to try to get this, and odds are that I will get very close to my opponent.
In general, be careful of rerolls. I think that is both a really good practical example, but
I
also
love rerolls as a mechanic,
Mhm.
but they're dangerous.
Yeah. I didn't say
Um,
don't use rerolls because yeah, I also enjoy them and I think it's really fun and gives you a sense of control over this random number. But yeah, be careful because statistically, things like that can happen. Um,
To go back to the
sorry.
original question, about is there an example of what was it of a mechanic that doesn't work as intended, right?
Mhm.
And I think that's the key point there. I think it goes back to intent. And as a designer, if you are designing a new game, the thing that you have to think about is the intent of this mechanic matching the actual math that's happening, and that's easier said than done. That's probably why you would want to have someone consult. So when you are doing the design, I think that's step one. What do I intend with this mechanic? Like, say, out of the blue, Deus ex machina, where God interferes in this particular instance. So I will simulate that with an auto success. But in this case, the God is the player. So,
Mm.
so is that what you're intending? Yeah, are you intending for God to skew to the player's favor all the time? Or with how many God points you have, for example? So that's something that you would consider, and then that's something that if you can't figure it out, that's when I recommend that you consult.
I
Yeah.
also
10 minute warning.
excellent. I in absence of other questions, I want to monologue a little bit about something like, so I think a lot of people think a lot that like the mechanic is separate from the design, but I think that's a really bad practice, right? And it's not just a bad practice, like, and it's very natural because, for example, like I design a lot for trophies, so I don't really think about the die mechanics because they're written in the system. Like, or if I design PBTA, like 2d6, I've accepted that. But people are risk averse or risk taking, and like people have a starting point, but the design of a game will affect, and like the narrative design of a game will affect how people actually feel when it comes time to roll the dice. And so if you want people to be pushing their luck with the die mechanic, and that's where the fun happens, and that's where the fun outcomes are, is when people really push it, then narratively you need to set them up to want to do that. And so I think that coming back to people don't have an objective sense of probability, I think it is really important, like it's like, oh yeah, and if you add that third die, something interesting happens. You want them then to add that third die, and so you need to set them up to do that. And so narratively modifying kind of your audience's risk-taking behavior is both entirely possible and happens all the time, and I think can be a really excellent addition to design.
So I have one other little mechanic anecdote that I am unreasonably fond of this little mechanic. So in After the War, once again, so you're rolling a pool of dice. Somewhere, it could 4 or 5 dice, whatever. You can take strain to re-roll as many of your dice as you would like. For every point of strain, you discard you add up your numbers together to get your total, and you discard any die that is equal to or lower than your strain. So, the first time is real easy. Oh, I discard all ones on my dice, but I get to re-roll all my dice. Okay. Second time, okay, I discard my 2s, but I still get to re-roll my dice, so I'll still go up. When you start discarding your 4s, but you can always succeed. You can always get 6s, and your 6s will still win. Until you max out your strain, you can still win. But I'm unreasonably proud of that mechanic. Just as a push your luck thing, this is the intended emotional experience, so... But yeah, so, any more questions? Looks like the audience is happy with us. Or terrified of the math. One of the two.
Yeah,
Could be both.
They thank you, Mags, for the insightful answer. That was from Clark. But other than that, there's no other questions right now.
Fantastic. Are there any other cool math things that people should know about? Oh, general basic thing. Don't worry, the math that you're using for games, for the most part, is easy math. Don't worry, most of the time you don't have to pull out calculus or trig. Like, we're talking probabilities, for the most part. So, don't feel intimidated. You can do this. And if you have a problem, you can always just ask the internet, ask other game designers, hey, I'm trying to do this thing. What is that called? And people will tell you, this is the fancy stats term. This is the fancy math term for the thing you're talking about. So you can find the answer.
So things get real fun when you're printing custom dice. And I'm just going to say that because you can do things like you can do rock, paper, scissors dice where it's a set of 3 dice, and for each die that one person picks, there's another die that will beat that one, usually on a roll, like 2/3 of the time. And it's just fun. But again, that requires a custom set of dice. And so I just want to say that there is fun stuff that's still familiar tools, but that would be a custom print job. I did introduce modular arithmetic in my game Dying in Space.
Nice.
And I was really happy with that. But then I did have to have like a page of the game. That is my game with Michael Van Vliet. That was about, here's how to do modular arithmetic.
The other thing, encounter tables. All of the things we were talking about for probability fall in for encounter tables. So, for instance, if you're rolling a 2D, if you have a 2d6 random table, shove all the ones you want frequently in the middle of the table. Shove the rare ones at the top and the bottom.
One of my sorry.
Yeah, go.
One of my favorite things about designing random encounters is that the lowest point and the highest points, especially in fantasy, for me when I'm writing my own encounter tables, is that those tend to be a wizard and a dragon or whatever the equivalent is for that setting. So if you are like in a say cyberpunk setting, the wizard will instead be some techie guy who will speak in technobabble, and then the 12 is going to be this super strong decked out enforcer of whoever the big bad is. And both of them are always interesting in a lot of RPGs. So that's how I structure my encounter tables typically. And then the ones in the middle, like you said, the most common ones. Although something that I also want to talk about is that while 7 is your most likely event, the likelihood of rolling a 6 or an 8 together is higher. So 6 and 8 are about, I feel like I put in similar things there with just some slight variations for my most common. And then the 7 is going to be like my most boring. Well, not boring. 7 is usually someone the player or characters already know. So that's how I personally structure 2d6 encounter tables. Sorry, that came out of nowhere.
No, that makes perfect sense. And so sometimes you'll want, here's a flat 1d6. You've got an equal chance of getting any of these items on the list. Whereas if you want to skew the chances, change the dice you're rolling. I mean, if you really want to have fun, you can do things like roll 4d4. Okay. You have an unlimited variety of dice you can play with. Have fun. And with that, I suppose we should all give our sign-offs, let people know where they can find us, and we'll let people have their evenings. So, my name is Jason Pitre, Genesis of Legend Publishing. You can find me at Genesis of Legend, or genesisoflegend.com. Mags, how can they find you?
Yeah, I'm Mags Maenad. You can find me on Twitter at MaenadMags. I linked my itch in the chat, so maenad.itch.io, and I am also here representing Cold Hearth Collective. So coldhearthcollective.com, that's my physical products.
All right. As for me, I am BJ Recio. You can see me at bukajuice.games. I have to update that website soon. Actually, I'll probably upload this video when it comes to YouTube. It's coming on YouTube, right? But where else can you find me? At Twitter, I am at BJ Recio. That's RECIO, BJ for Buka Juice. And then I am part of RPG SEA, RPGC. It's a hashtag for calling people's attention to games that are being made in Southeast Asia. We've always been here. It's just that we are only getting visibility now, thanks in part to the hashtag, I suppose.
All right,
So,
thank you all for joining us. We will let you be. Have a good time zone.